Before dawn on March 5, 2026, the ground beneath northern Louisiana moved in a way it hadn't moved in nearly a century. No warning, no tremor building slowly through the night. Just a sudden, violent shudder radiating outward from a point roughly 36 miles southeast of Shreveport, a place called Edgefield, where the flat Louisiana landscape offers nothing between you and the shaking earth beneath your feet. Over 1,100 people felt it. Doorbell cameras captured the moment windows rattled and walls groaned. And when the USGS confirmed the magnitude at 4.9, seismologists paused. Because in a state that most Americans would never associate with earthquakes, something remarkable and deeply unsettling had just happened. But the number itself is only the beginning of this story, because beneath that single measurement lies a pattern, a set of unanswered questions, and a geological reality that Louisiana has been quietly ignoring for decades. The earthquake struck at approximately 5:30 in the morning, Central Standard Time. Most people were still asleep. In towns across the Ark-La-Tex region, that three-state overlap of Arkansas, Louisiana, and Texas, residents described being jolted awake by a sharp, rolling sensation. Not the long, slow sway of a distant quake. This was close. This was shallow. And that combination matters enormously. The USGS recorded the event's depth at approximately 11.1 kilometers, roughly 6.9 miles below the surface. In seismological terms, that is relatively shallow. The shallower an earthquake, the less distance the energy has to travel before it reaches the ground surface, and the more intensely it is felt by everything and everyone above it. A magnitude 4.9 at that depth delivers a dramatically different experience than the same magnitude at 30 kilometers. The shaking is sharper, more abrupt, more disorienting. At the USGS Earthquake Hazards Program, the event was logged and confirmed. Local news stations KSLA in Shreveport and WWL-TV out of New Orleans were reporting within hours, both citing USGS data and reaching out to geologists for context. AccuWeather picked up the story shortly after. The characterization that emerged from these verified sources was consistent and striking. This was the largest inland earthquake Louisiana has ever recorded, and the largest in approximately 96 years. That phrase, largest in approximately 96 years, carries a kind of geological weight that takes a moment to absorb. The last time the earth moved this forcefully beneath Louisiana's interior was around 1930. There were no social media posts then, no doorbell cameras. Just people in wooden structures feeling the ground betray them with only a rudimentary scientific framework to explain why. Now there is a more complete framework, and what it reveals is more complicated than a single headline, but that's only part of the story. To understand why a magnitude 4.9 earthquake in northern Louisiana is scientifically significant, you have to understand what Louisiana's ground is actually made of and what has been happening beneath it. Louisiana sits on ancient sedimentary basins, thick, layered sequences of rock and compressed organic material built up over millions of years. The northern part of the state, around Shreveport and the parishes that extend south toward Edgefield, overlaps with one of the most productive natural gas formations in North America, the Haynesville-Bossier Shale. This is not a quiet geological zone. It is an actively exploited industrial landscape where hydraulic fracturing and fracking has been pulling natural gas from tight rock formations for years. The process involves injecting high-pressure fluid into the earth to crack rock and release trapped hydrocarbons. And across multiple states and multiple decades of research, that process has been linked, with varying degrees of certainty, to something called induced seismicity. Earthquakes, triggered not by natural tectonic stress alone, but by human activity altering the stress distribution inside the earth. The USGS has documented this phenomenon extensively. In states like Oklahoma, Kansas, and Ohio, regions with negligible earthquake histories saw dramatic seismic upticks that tracked almost precisely with the expansion of oil and gas injection well operations. The mechanism is not always direct fracturing. Often it is the disposal of wastewater produced during extraction, injected back into deep rock formations, that lubricates pre-existing faults and allows them to slip. In Louisiana, geologic surveys following the March 5th event were described as pending. Researchers indicated that unknown faults in the Haynesville-Bossier Shale region needed to be identified and mapped. That phrase deserves emphasis. Unknown faults. in a zone that has been industrially exploited for years, scientists are acknowledging they do not have complete knowledge of the fault structures that underlie the extraction operations, and the timeline of recent seismic activity adds urgency to that admission. Since December 4th, 2025, just 3 months before the magnitude 4.9, USGS records show 10 earthquakes in this region with magnitudes ranging from 2.6 to 3.1. 10 events in roughly 90 days in a state where the annual average is only around 5 earthquakes above magnitude 2.0 for the entire year. Something changed. Something shifted. Whether that shift is the result of natural stress accumulation, industrial pressure on pre-existing faults, or some combination of both, remains officially undetermined. But the pattern is there, and it is not subtle. Yet what comes next could be even more consequential than the shaking itself. Louisiana does not think of itself as earthquake country. That is not a criticism. It is simply a product of history. The state's seismic record is sparse compared to California, Alaska, or even the central United States. Most residents have lived their entire lives without feeling the ground move, and that absence of experience creates a specific and dangerous vulnerability. Structures in Louisiana are not built to seismic standards. Unlike California, where building codes have been revised repeatedly following major earthquakes, Louisiana's construction norms reflect its actual historical hazard profile, which is classified by the USGS as low. Homes, commercial buildings, bridges, and infrastructure across the Shreveport region were designed with wind, flooding, and storm surge in mind, not ground shaking. This matters because a magnitude 4.9 at shallow depth, while not catastrophic in a seismically prepared region, interacts very differently with structures that have no seismic reinforcement. The lateral forces generated by ground shaking can crack foundations, displace chimneys, and compromise the structural integrity of older masonry buildings, the kind that are common in older neighborhoods across northern Louisiana. On March 5th, no significant damage was reported, no injuries, no deaths. Emergency management in Louisiana issued no active alerts as of March 8th. By the conventional metrics of disaster assessment, this event was minor. But here is where history offers an uncomfortable mirror. The most instructive parallel is not another Louisiana earthquake. It is the broader pattern seen in Oklahoma, where a state that averaged 1 to 2 magnitude 3 or higher earthquakes per year before 2009 saw that number explode to over 900 in 2015 alone. During the peak of the fracking and wastewater injection boom, structures in Oklahoma were also not built for seismic loads. Damage mounted steadily. And the crucial warning, the point at which scientists publicly raised the alarm about induced seismicity, came only after the escalation was already well underway. The question being asked quietly in geologic circles following the March 5th event is whether Louisiana is watching the early chapters of a similar story. 10 events since December, a magnitude 4.9 that no existing fault on any current map can definitively claim. A shale extraction zone that has been producing gas under hydraulic pressure for years, and a population with no seismic culture, no earthquake preparedness infrastructure, and no building codes designed for this kind of stress. And now, scientists fear history may be repeating itself. The deeper you look at the record, the more the March 5th event seems less like an isolated shock and more like a signal. Louisiana's largest earthquake on record occurred on February 9th, 2006, a magnitude 5.3 offshore near Grand Isle in the Gulf of Mexico. That event is offshore and likely related to entirely different geological dynamics. The March 5th quake is the second largest in state history overall, but it holds a separate and arguably more significant distinction. It is the largest inland earthquake Louisiana has ever recorded. The previous benchmark for significant inland seismicity was a magnitude 4.2 near Donaldsonville, Louisiana, recorded in 1930. That event also occurred in the southern part of the state. The geography of the current event is striking in its own right. Northern Louisiana sits above the deep Haynesville Basin, where sedimentary layers and the faults that cut through them have been subjected to both natural geological stress and, more recently, industrial modification. The current seismic hazard rating for Louisiana remains officially classified as low. That rating is based on the historical record. But the historical record is precisely what changed on March 5th. When a region produces the largest inland earthquake ever recorded in the state, the question of whether low hazard remains an accurate description becomes legitimate. USGS protocols call for ongoing monitoring and aftershock assessment in the weeks following a significant event. As of March 8th, no aftershocks had been detected. The 7-day probability of a magnitude 3.0 or greater in the area was assessed as low. By the statistical models, the immediate acute risk is low. But the New Madrid seismic zone, that ancient and formidable fault system spanning southeastern Missouri, northeastern Arkansas, western Tennessee, western Kentucky, and southern Illinois, sits not far to the north. Geologists are careful to note that the New Madrid zone does not pose an immediate local risk to the Edgefield area, and the March 5th event should not be conflated with New Madrid activity. These are distinct systems. But the New Madrid zone is a reminder that the central and southern United States is not seismically inert, and that the quiet periods between major events in this part of the continent can last centuries, long enough for entire civilizations to forget what the ground is capable of, because what happens next could rewrite the assumptions this region has built its infrastructure on. What geologists are left with in the days following the March 5th earthquake is a set of questions that the data raises but cannot yet answer. Is the seismic uptick since December 2025 a temporary cluster that will fade, or the early signal of a more sustained period of elevated activity? Is there a fault, or multiple faults, beneath the Haynesville-Bossier Shale zone that has been accumulating stress, either naturally or through industrial loading, to a degree that produces larger events over time? And if so, how large could those events get? The pending geologic surveys will attempt to map faults in the region more precisely. But fault mapping in deep sedimentary basins is difficult and time-consuming. The structures that matter most are often the ones buried deepest and detected last. One geologist interviewed by local news in the days following the quake offered a phrase that captures the situation precisely. We are looking at an area that we did not think needed this level of scrutiny before, and now it does. That recalibration, the shift from low-priority monitoring to serious investigation, is itself significant. It reflects a community of scientists acknowledging that their existing models did not anticipate this event and that the models may need to change. Louisiana residents across the Arc-La-Tex region who felt the ground move at 5:30 in the morning on March 5th already know something shifted. Not just the earth. The understanding of what this land is capable of. Over 1,100 people filed felt reports with the USGS. Each one of those reports is a data point, a piece of a picture that is still being assembled. What that picture ultimately shows, whether this was a singular historical outlier or the most visible tremor in a sequence that is still building, will not be known for months, possibly years. The Earth doesn't announce its intentions, it keeps its own timeline. And in a state that had not felt movement like this in nearly a century, the unsettling truth is that the ground beneath Louisiana just reminded everyone that it has been here far longer than the structures built on top of it, far longer than the pipelines drilled through it, and far longer than the assumption that it would stay quiet. Stay safe, stay informed, and keep listening to what the Earth is telling us.